Our next question is, how can we make use of that? We know that, right? We know that how it works, but how we can make use of that? How we can write a method that can use recursion? So here is the tip for you. We start from computer can always solve subproblem automatically. Given that, can we solve the whole problem, and can we find the base cases to solve them? So you remember this one very clearly, and this is how we can solve problem. Let's go back to the power again. Let's go back to the places when we don't have anything. Now, let's ask ourselves, computer can always solve subproblem automatically. It means that somehow, right? Just assume that computer has already solved the problem with the power subproblem. So with the power something smaller. So this one, computer has solved it for us already. So if the computer has solved this problem with x and y minus 1, x to the y minus 1, we ask ourselves, can we solve the problem? If the computer has helped us to solve the problem with x to the power of y minus 1, how can we solve the whole problem? Can we? Of course we can, right? We can easily assign this one to some variable, right? So temporary or something. And after that, we can return, or we can compute the final value equal to the temp value and multiply by x, one more x. Isn't it? So because the computer can always help me to solve this smaller problem, then I can, based on this smaller problem, I can get the final calculation for me. And of course, because this method needs to return the value, then I need to return the final value. We're done. So this is the first step. The second step is that we need to find the cases, the base cases. How can we find it? So in here, this one is, there's two smaller steps. The first one is that because there is a subproblem, we need to say when the subproblem smaller, when it's reached the point that it can perform without calling the method. So look at here. Here, we say that, oh, the smaller problem is that y will be minus 1 slowly. So y minus 1, to the point that we don't need to call itself anymore. It doesn't need to call itself anymore. Which point? Which point is it? When? Maybe when y equal to 1. If y equal to 1, it means that x to the power of y, x to the power of 1, it means that it's return x, right? So if y minus 1, if y equal to 1, then we don't need to call anymore. We just return x. Isn't it? And now because of the programming here, it say that it's unreachable code because we do the return in here. Because of that, we need to move this one up in here. We need to check y minus 1 first. And then we can solve the problem already, because we can solve the whole problem given the computer solved the subproblem for us in here. We can solve the sole problem. The second one, we can find the base case already. So two things we have solved already. This one can run. So let me run it again. Oh, I don't need to get this one anymore. Continue. Run again. You see? We'll have this result. All right. So the next part is just to simplify the code, right? Because this one is a temporary. Actually, we don't need the temporary here. We can replace everything. All right. And after that, because this one is a temporary, a variable that's used only once, so because of that, I can return it right away. Right? And of course, I can say x multiple by this power, or this power multiplied by x. Same thing. Right? And in some situation, the base one, maybe you don't need the one. Maybe you can see that, oh, again, right, I can decrease y to y minus 1, etc. to the point that y equal to 1, or even to the point that y equal to 0. If y equal to 0, still fine, right? If y equal to 0, then we return 1 instead, because x to the power of 0 is 1. So this is how we use the technique of this one in order to design our recursion method. So I hope you enjoyed the video, and thank you very much.